Welcome back to Understanding Signal Isolators, Converters, and Interfaces. In our last video, we covered the fundamentals of signal conversion and why it's essential for reliable process monitoring. We learned how converters translate legacy current and voltage signals into standard 4 to 20 milliamp signals, how fixed, field configurable, and PC configurable designs differ, and how AC signals from motors and equipment are safely stepped down using CTs and mini CTs. We also explored digital conversion, mapping HART data to Modbus for easier system integration. In part 4, we'll focus on the functional roles of signal isolators and how they're used to solve real-world installation challenges. We'll examine how isolators protect and divert signals between systems, how splitters enable one transmitter to drive multiple control systems safely, how isolators resolve bucking power supply issues, and how they can even provide excitation power to two-wire transmitters. Together, these functions ensure reliable signals, safer maintenance, and more flexible system design. In many applications, a single process variable needs to be shared between two systems, such as an emergency shutdown system and a BPCS, or a control system and a data acquisition system. Creating a single series loop between both systems isn't acceptable because disconnecting one input for maintenance would cause both systems to lose the signal. Area isolation solves this by using a signal isolator to split the loop electrically. One system is designated as the primary and powers the transmitter, while the isolator creates a fully isolated secondary loop. This allows maintenance on the secondary system without interrupting the primary, protecting critical signals while keeping both systems operational. While area isolation protects a shared signal, it does come with a limitation. If the primary system is taken offline, the transmitter loses power and both systems lose the signal. When full independence between systems is required, a different approach is needed. That's where signal splitting comes in. A signal splitter is a four-wire isolator or converter that takes a single input and generates two or more identical, fully isolated outputs. Unlike area isolation, the splitter provides its own 24-volt transmitter excitation, powering the transmitter directly. This means either the control or monitoring system can be disconnected from maintenance without affecting the other. Because of this independence, signal splitters are commonly used in applications like custody transfer and isolating validated systems from non-validated systems in pharmaceutical and bioprocess facilities. Beyond sharing signals between systems, isolators also solve power conflicts that can occur inside the loop itself, especially when powered devices are connected where they shouldn't be. Some BPCS systems use lower-cost 4 to 20 milliamp input cards that must power every loop connected to them. This works fine with loop-powered transmitters. However, when a four-wire device, such as a line-powered transmitter, is connected, both sides of the loop attempt to source current. The result is bucking power supplies, which can cause unstable readings or no signal at all. An output loop-powered signal isolator resolves this conflict by electrically separating the powered devices. It allows both sides of the loop to remain powered while restoring a stable, accurate 4 to 20 milliamp signal to the control system. In many applications, it's convenient and cost-effective to power a two-wire transmitter directly from a four-wire signal isolator or converter installed in the loop. This approach is known as transmitter excitation, or TX. The isolator provides a built-in 24-volt DC power supply, eliminating the need for a separate instrument power supply. By combining signal isolation and transmitter power in a single device, transmitter excitation simplifies wiring, reduces panel space, and lowers overall system cost, while still delivering a stable, reliable 4 to 20 milliamp signal to the control system. In this video, we explored some of the key functional roles of signal isolators in real-world systems. We saw how area isolation protects shared signals between control systems, how splitters provide fully independent outputs for maintenance and critical applications, how output loop-powered isolators solve bucking power supply conflicts, and how transmitter excitation allows isolators to power two-wire transmitters directly. Together, These functions improve system reliability, simplify installations, and keep process signals accurate and available.